Welcome back, Algebra 2. We're in Lesson 109. We're going to talk more about fractional exponents. In Lesson 38, we noted that the power rule for exponents can't be used when the base is a sum. So that means if my base is a sum of x plus y and it's squared, I cannot just say x 2 times this 1 and say x squared plus y squared. It does not work that way, and here's why. Because when you have the whole thing squared, this whole binomial is squared, you're saying the binomial times the binomial, and you have to distribute accordingly. So we have to stack it, and then we have to solve. So y times y is going to give us a y squared. Y times x is xy. X times y is xy. And x times x is x squared. So when we add those together, we get 2xy plus y squared plus x squared. So you can see that is definitely not the same thing as we would get if we just applied the power rule on the exponents. You have to take into account that middle term that comes from the distribution process. And that's why it also cannot work for fractional exponents as well, because of that distribution property. So let me clear this, and let's move on. All right, let's look at, I'll move this over just a bit right there. All right. Let's look at 109.1. We have, let me write it up here for us. Now, when we have all factors, these are all multiplied against each other, and you have an exponent, you can just multiply this times this, because what we have is this. This would equal 2 times 2 times 2 times x and 1/2 times x and 1/2 times x and 1/2. You see where I'm going with this, I'm sure. Times x, or y to the 1/4 times y to the 1/4 times z times z times z. So that would be 8, and that would be x to the 3/2, because we just add those together, y to the 3/4, and z to the 3rd. Well, if we just multiply the exponent times these, so that'd be 2 to the 3rd, which would be 8. And then we have 3 times the 1, that'd be 3 over 2, x, 3 over 2. 3 times the 1, that'd be y, 3 over 4. And then there's a little 1 right here. 3 times that 1 would be z, 3. So you get the same answer. So therefore, that is the way you do it when everything is a product. The product rule for exponents is what you're using if you need reminding of which one that is. The product rule. Product means multiplication. All right, let me clear this. Let's look at 109.2. All right, now why does it not work when we have a sum? Because you're not just multiplying the powers together. There's another operation here. They're not factors to each other. So the product rule does not apply. They have to all be factors. The entire thing has to be multiplication in order for the product rule to apply. When we have a binomial with an operation, we have to use the distribution method. I like to use stacking for distribution, so let's try that. Or let's use that. Let's x and 1/2 plus y and 1/2. And technically, when you have that plus sign, we know that that's a positive here. The only time you really worry about the operation is if this were negative, and then you just attach it to the y, and that would be a negative y. We know this. And now I'm going to write it again because we're doing it twice. So x and 1/2, y and 1/2. So what happens when we multiply two variables? What happens to the exponents? We add them together. So 1/2 and 1/2 is 1. So y to the 1. Okay. Same thing here. We have y to the 1/2, x to the 1/2. They're not like variables, so we just write them as products to one another or as factors to one another. Same thing here. It's the same multiplication. We'll stack that, and then we'll multiply these, and we get a whole x because 1/2 and 1/2 is a whole. And then our answer is x plus 2x to the 1/2, y to the 1/2, because there's this invisible 1 right there, plus y. And that is not the same thing that we would have gotten if we had just multiplied here. If we had just multiplied here, we would have gotten x plus y. We would have completely missed this middle term. And that is why we cannot just use the power rule for exponents when we have a base here. Okay, let's move on to 109.3. All right, so in 109.3, we have a negative exponent. Otherwise, it's the same problem we had previously. So let's stack. And then we're doing it twice. So x and 1/2, y and negative 1/2. We add these together. We get y to the negative 1. We have x and 1/2, y and negative 1/2. We have another one of those, x and 1/2, this one times this one, y and negative 1/2. And then we have x 1/2 times x 1/2, and that's just going to be a positive x to the 1. So when we add all these together, we get x plus 2x to the 1/2, y to the negative 1/2, and then a positive y to the negative 1, and that would be our answer. All right, now something that you might be tempted to do, and it could work, just looking at this, I'm thinking to myself, why can't I just use the exponent here and the exponent here and then multiply these against each other twice and add them in? That's exactly what you could do, because that's what we did. If you look, this times this, negative 2 over 2 is a negative 1, and positive 2 over 2 is the 1. So you're getting this one, and you're getting this one by using the product rule. And if you multiply x and 1/2 times y and negative 1, you get this one. And if you do it, and if you just do it again, you just double it, then you would get your middle term. So you can do it like that, but it's about the same amount of work as stacking it and doing the distribution anyway. So why not just do the stacking method or just do the distribution if it's going to be the same amount of work and the same amount of steps. All right, that's all I have for lesson 109. I will see you ladies and gentlemen in lesson 110.